Good afternoon and welcome to Tuesday Talks at the White House, a weekly invitation for people around the country to engage with administration officials, policy experts, and more. This week, President Obama will award recipients of the National Medal of Science and the National Medal of Technology and Innovation, the highest honors bestowed by the United States government on scientists, engineers, and inventors. For Tuesday Talks this week, we're so honored to have with us three of these medal recipients. Warren Washington to my right, Stephen Sasson, and Marianne Fox. Thank you so much for joining us today.
Thank you.
I'm Corey Schulman in the Office of New Media, and for the past couple of days, you've been sending us your questions on Facebook and whitehouse.gov for the medal recipients to my right. We're going to get to your questions soon. If you're just joining us, go to whitehouse.gov/live. There's a link to Facebook where you can join the chat, and we will be answering as many of your questions as we can in the live chat. Before we hop into your questions, I'm going to turn it over to the medal recipients to my right to give a bit of background on themselves and what it means to be honored in this way tomorrow. So maybe, Warren, can you start?
I'm Warren Washington. I'm from the National Center for Atmospheric Research in Boulder, Colorado. I've been involved in the modeling of the climate system since 1964. Our group was one of the pioneering groups to put together computer models. And since that time, the area of climate change has become very important. And we actually can carry out simulations of the recent past climate into the future so that we can give information to society and to the policymakers. I come from a physics background and mathematics background, and that's what really got me started at Oregon State University and then at Penn State for my PhD.
Thanks. Stephen.
I'm Stephen Sasson, and I have been a member of the Eastman Kodak Company for over 35 years. And in that duration of time, I've spent my entire career involved with digital imaging. And so I've been part of the big transition from silver halide imaging to digital imaging over the last 3 decades. I got interested in this because I was interested in electronics as a young person. I grew up in Brooklyn, New York, and I went to Rensselaer Polytechnic Institute, where I got a bachelor's and master's degree. And I've been very honored, extremely honored to have been recognized for this award. And I'm very proud of the award. I'm proud also of my company and the people that I've worked with for all those years.
Hi, I'm Marianne Fox. I'm the Chancellor of the University of California at San Diego and a physical organic chemist. I think the thing that our research is most known for is photo-induced electron transfer and how it plays out solar energy and environmental remediation. We've been very interested in problems that relate to interfaces between solids and gas, gases and liquids, liquids and gaseous states, and being able to change reactivity by changing the characterization of that interface at the nanoscale size. I'm delighted to have received this award. I think it's a tribute to my many brilliant students and colleagues who've worked on these problems for several decades. Delighted to be here today.
Thanks. Jamie West in the chat has said, hi Warren, hi Stephen, and hi Marianne. So,
Hi.
Hi. Hi Jamie. Okay, so the first question, this comes from Donna Marie Buchan Alcott. And this is Donna Marie's comment and question. Given our current standing in the world in terms of science and math aptitude of high school students, and our diminishing numbers of those going into science and math careers, what should be done to turn the U.S. back into a science and math technology leaders? What motivated you and intrigued you about your field of study? And how can a parent motivate a gifted child to achieve his or her potential? So it's many parts to that question, but whoever wants to take it away first.
I think quality STEM education, science, technology, engineering, and mathematics, really represents the future, not only of the United States, but globally as well. It's been very important to see how teaching methods evolved to focus on the effectiveness of science and engineering in particular. And I'm happy to have been involved in science education to this day.
I think this is a very good question, and it's a critical issue for our country. I'm a big believer in letting people have fun with science as well. I think we have to get away from being always right all the time. I like to say that we should encourage people to make mistakes because that's how you learn. And I like to say that inventors spend most of their time being wrong. And so we have to celebrate the fact that people have to explore, make mistakes, and go forward. And sometimes the educational system sort of try to be very efficient in always getting the right answer, when sometimes the wrong answer. You learn a lot more from it. That plus enabling our science teachers with more tools, more background, more education. Technology is very hard to keep up with for anybody. And so we have to really enable our science and educators to be able to kept up to date with the latest technology. And that requires a significant effort. We have to make it.
Yeah, if I could just add one more thing, and that is that I think that students who are in either junior high school or high school should be encouraged to take advantage of various summer programs. I think that they can learn that science and engineering and technology occupations are interesting and challenging. I think that too many students are turned off by the fact that they just don't see themselves getting into any of these fields. And by having some good summer experiences along with exciting science teachers, I think is going to be very critical to us changing things around.
That's a really good point, Warren, and I think we have to recognize a lot of learning in science and engineering occurs outside of the classroom. I was very pleased to see President Obama have the science fair within the White House, and to see the organization that Larry Bach brought to the mall, drawing tens of thousands of viewers and participants. It's really very encouraging.
Okay, the next question, this comes from Alan Goretsky, and this is mostly directed towards Stephen, and a number of people have been asking similar questions. He asked specifically about Kodak, but more broadly about digital photography. It's changed so much over the last decade. How do you see it evolving over the next decade?
Well, it certainly has changed over the last several decades. What's happened is the ability or the opportunities people have to take their photographs have expanded. Back 30 years ago, the photography system was based on silver halide, which gave great images. But when we introduced digital photography, we not only get great images, but we also have the ability to share our images instantly. So imaging now becomes more than just a way to memorialize events. It's a way to have a casual conversation, as many people do on Facebook and all the rest of the media sites. So it's been an enormous change, and we're all adapting to it. And in the future, I think we're going to face some additional challenges. I mean, images are everywhere now. So perhaps we'll be better behaved because we're always on camera, it seems. And I also think that the pictures that we do capture, whether they be personal pictures or professional pictures, there's more of them. So the ability to find them, to store them, to share them is always going to be a challenge. So as we go forward, we're going to have more opportunities, but we also have to have a way to organize these so that we can use them. And there's also the issue of format obsolescence. You know, what you store your images on today, 10 or 15 years from now, may not be the medium of choice. And so there's always a way you have to always upgrade that storage. So that's going to be a challenge as well. But there's opportunities that have never been better for imaging. Pictures are everywhere. It's sort of the universal language. And I think it's just only going to get more interesting from here on out.
Thanks. If you're just joining us, go to whitehouse.gov/live. Click the link to Facebook. There's a live conversation happening right now where we're getting a lot of great questions for these 3 medal recipients that will be honored tomorrow for the National Medal of Science and the National Medal of Technology and Innovation. We have a question that just came in from Joshua Gage, and this is on climate change. On climate change, we can change the things like emissions from daily use in household items and transportation, but not nature. How many years will it take for us to see the effects of volcanic eruptions?
Well, we can see on the volcanic eruptions in terms of their effect on the climate system very easily. If we have major eruptions, the cooling of the Earth caused by aerosols in the stratosphere can last of the order of 18 months. But I don't think that you should think that the volcanic eruptions are going to actually save us from global warming. Every time that you burn a molecule of carbon dioxide is generated, it has a lifetime of roughly 90 years. So the scientists are very concerned that that if we don't cut emissions now, that we're going to cause on the Earth to warm up substantially over this next century or so. So it's very important that we cut emissions to the lowest possible levels early so that we can forestall major climate change at the end of the century and into the next few centuries.
Okay, I've got another question for you. This comes from Nancy Orr. She asks, Dr. Washington, what do you think of the manipulation of climatology research for political means by both sides of the debate?
Well, this is a very difficult issue. Obviously, there's some people who don't want to see anything done about climate change, and others who are very zealous about dealing with the environment. I think that the important thing is that the scientists of the world have got together and tried to give very reasoned, carefully worded statements to the policymakers. And I think there's been a lot of misinformation about climate change. And unfortunately, it's hard for the public to separate on the two. I think in terms of the bottom line, I would essentially recommend that people follow the statements that come out of things like on the National Academies of Science and Engineering about climate change, because they have tried to look at all aspects of the problem and provide policy recommendations to the policymakers. And I think that all of those statements are very carefully worded so that there's no misunderstanding of the consequences of climate change.
Thanks. This next question I think is best directed towards Marianne. Livu Stoiseku, pardon me if I did not pronounce your name correctly, asks, is chemistry important or very important?
Chemistry is very important because it's, in my opinion, the central science. If you know chemistry well, you can move to the interface with physics or biology. You can do medicinal work. You can develop new drugs, new natural products. So it's quite central, I think, to progress.
Okay. The next question comes from Kurt Coates. Kurt asks, what can we do to make solar panels more efficient and cost-effective?
Well, we've worked a little bit with the basic science that goes on in solar panels. And of course, what you want to do is to have nanoscopic control so that you can control the particle aggregation that leads to imaging and to separation of charge. Whether that gives practical consequences in terms of financing for installation of solar energy is the next generation, but one that is conceivable.
I wonder if I could just add one more thing to what Marianne said. Clearly, this is an example of where the technology keeps developing, and that we're finding that we can bring down the cost, and that we can make the on the solar panels much more efficient. So an investment in the science and the engineering and the technology has paid off, I think, in terms of giving us a better product.
It's an example, too, where basic science has led to practical applications in a very short period, really.
Okay, we've got a question. This came in from Nick Izzo to the man from Kodak. I think he's talking about you, Steve. Sorry, I missed your name. Did you experience resistance to your discoveries in digital imaging from your superiors because there was a threat to the film business? Can you say anything about industries being forward-looking and taking advantage of new technologies instead of holding on to new ones that will become obsolete?
Well, it's a good question because, as you know, Kodak as a company had been around for well over 100 years. And And so when you have a new, what I would call a disruptive technology that potentially could affect the business, you obviously get lots of questions, and you get a lot of, lots of really critical questions. And yes, when I developed the digital camera, yes, I was challenged quite a bit. But they were reasonably good challenges. You must remember that when you develop something for the first time and you put it out there, you're judging it in the present day context. That is, back in 1975, when I took my first images, there were really no personal computers around. There certainly wasn't any internet or any of the things we take for granted today. So you can understand how people would be a little skeptical about what I called filmless photography at the time. Having said that, I think inventors have to recognize that when you move forward with an idea, you have to recognize that the whole world's inventing along with you, and that your idea may mature with additions from other fields to something different than what you possibly could imagine. When I first proposed digital photography at Eastman Kodak Company, I wasn't thinking about the internet or any of the desktop photographic printing that we take for granted today. And so consequently, I just thought of it a way as to not have a consumable and to capture images. But it's become so much more than that. And that's because of all the other developments that were being done in parallel fields simultaneously. And then they all sort of coalesced in the late 90s into the infrastructure which we celebrate so much today and we take for granted so much today. Pictures on over the internet, on Facebook, for example. We sort of take that for granted right now. But I don't think that was, it certainly wasn't in my thinking 30 years ago, and I don't know too many people who did have that thinking. So, yes, you will always be challenged. Any good corporation always has to challenge itself in its fundamental basic understanding of what they're based on, and you have to give people enough freedom to explore that. I was given that freedom, and a number of people at Kodak did a lot of pioneering work in digital imaging, not necessarily talked about so much, but it was actually done. So companies really have to do that. If they don't, they do it at their own peril.
Okay. If you're just joining us, go to whitehouse.gov/live. There's a link to join the live chat on Facebook where we're scanning your questions. There's a very active dialogue happening right now, and we're trying to answer as many of your questions as we can. The next question comes from Chang Yu Yen. She says, congratulations to all of the honorees. Great idea to have this discussion forum. Thank you all for participating. What are 3 things government can do to help our country become more energy independent in 10 years? And what are 3 things individuals can do to help?
Wow.
I might not hold you to 3, but...
Start at the other end.
Well, I think that we could at least start implementing in a faster way on present technologies. It's sort of worrisome to me that China, which is a very large emitter of carbon dioxide and other greenhouse gases, has also jumped in to take the lead on implementing renewable energy sources, and that we seem to be holding back for some reason. And I think that by holding back, we aren't making the transition that we need to make.
Yeah, I would agree with what you said. I also think that as individuals, we just become aware of our actions and what they can mean. I don't know, everybody talks about the light bulbs and things like that, but there are many things that we can do to sort of become a little bit more efficient in the way we utilize energy. And I think that's something that I think we've all become more aware of over the last 10 years. But I think in the end, science and technology are going to be able to help us, lead us out of this. And we've got to, as Warren indicated, we've got to make a real serious effort at this. This is as critical a crisis as we have. And unless we address it in an intelligent and organized way, we won't be efficient at getting the solutions. In fact, others may reach those solutions earlier than us.
I'd say the third contribution that needs to be made is adequate support for science education. Science in the public interest has to be something that's understood well by the public. Otherwise, they'll never understand the requirement for investment going forward.
Okay, thank you. The next question comes from Brenda Hogland. Brenda asks, does the White House have solar power? There are a lot of people that would love solar or wind power, but no way to afford it. And what is being done to produce sorry, the last bit. So let's stick to the first bit, which is, does the White House have solar power, and are there ways to make it more affordable for those that are interested?
I don't know.
I think that they've just recently installed some solar panels at the White House, as far as I know, and I don't know if it's fully functional or not.
I can tell you we have solar trees at the University of California, San Diego. I have solar panels on my own house. That was with some government subsidy, some incentive to achieve that. But I must tell you, my husband goes out almost every day and watches the meter go down. He really likes that in California.
Okay, the next question comes from Andrew Wade Nunn. This is for you, Stephen. Do you think that digital photography has eliminated any portion of the raw fundamentals of photography that come with standard film photography?
Perhaps he means like artistic form and
I believe
creativity.
so.
Is that what they're indicating there?
Yeah, that's my sense.
I think, you know, the technology has changed, but the art stays pretty much the same. Great photographers are great photographers. They're great storytellers, and whatever technology they use, they learn to use that technology to tell their story. So I've known some really great photographers, and they've done it with film, and they've done it with digital. You know, the technology changes, but their mission stays the same: tell the story in an elegant and artful way. That's what they do. So no, I don't think digital has taken away. I think it's added.
Okay, thank you. This question comes from Nancy Orr. Dr. Washington, what do you think of the manipulation of climate? Oh, we've already addressed that question. I'm going to move on to a different one. This comes from. Sorry, we've got a lot of questions coming in. If you're just joining us, go to whitehouse.gov/live. You can click the link to Facebook, where there's a very active discussion, and I'm just trying to find some of your latest questions. This one comes from Nancy Orr. This is for Dr. Fox. What's the next big thing in chemical photonics?
The next big thing in chemical photonics is understanding how size influences excited states. So we've already seen in the Nobel laureate work of Roger Chin that there are a number of dyes that can be used as markers for biological events. I think photonics will develop a whole range of materials differing in size and character and shape that will revolutionize our ability to manipulate molecules.
Okay, we just had a question come in from Ruth Ness. This is for Dr. Warren. Who was your favorite science teacher, and was he or she better than Terry Chiacco? I don't know if that means anything to you.
Oh.
Your favorite science teacher.
Oh.
Okay.
Well, I was very fortunate to have in high school a chemistry teacher who did not answer the questions that students asked. She asked the students to turn around and try to find out the answer. And I thought, I asked them the question of why egg yolks are yellow, and she said, find out. And it took me maybe a few weeks to research on the literature. Found it had to do with seeds and on the food that eggs eat that had sulfur compounds in them. And I wouldn't have found that out, I wouldn't have gotten started in science if that teacher had just answered the question. I think on the quest of looking into it and trying to find out is what excited me about going into science.
Relevant to that same question, the Nobel Foundation is trying to stimulate young people, junior high and senior high, to provide questions, not answers. So it's very much similar to what you're suggesting, that they're doing a competition.
Now, it's actually a question I'd like to extend to each of you. The Department of Education just launched a site called teach.gov, and they're asking a lot of fascinating people about their favorite teachers. So do you have a favorite science teacher or inspiration?
You know, yeah, I went to my freshman year at Rensselaer Polytechnic Institute. I had a recitation session with a Dr. Robert Resnick, who was a very famous physics teacher. And I must tell you, the guy was amazing in the sense that he really inspired me to the point where I'd do my homework, go to recitation, and then I'd see the elegant way in which he solved those problems. Absolutely elegant. He made it just look so easy, and I struggled for hours to get, I might even get the same answer, but he did it so elegantly. I'd go back to my dorm and redo the problems. I never did that before in my life, you know. And so to answer your question, I think it was Dr. Resnick. He was very, very inspiring to me.
I think there's a continuum between teachers and mentors, and I had more mentors than I had teachers that did that same stimulation. The mentors I had helped me understand how science policy is done, why education is important, and why it's very important that people who end up in administration, as I have, continue their research group to keep active and alive in the classroom.
Okay, the next question comes from Darlene Matthews. What would each of you propose as the most important item to focus on as we're developing tech in the future? So technology or sort of in your own field, what do you view as the most important item to focus on?
You mean technology or?
This is technology specific, but feel free to expand on that. It's a big question.
Yeah, well, at least I think that just keeping up with the pace of technology, for example, the internet and the way that we communicate has been wonderful, but it's also meant that you've really had to stay on task to be able to take advantage of all these new technologies. Now there are some negative aspects to it in that when I log on in the morning I have 50 or 60 emails to sort of deal with, but I've learned how to efficiently go through that. But on the other hand, on the positive side, it keeps me in contact with lots more people and lots more colleagues.
Yeah, I agree, Warren. The more technology we have, the further behind I feel. It always seems to be that way. I don't know what the most important thing is. I think I agree with Warren. Just keeping up is a major challenge for people, and so that means you have to be more selective in what you concentrate on, which in turn means that you have to depend on your fellow scientists and explorers to focus on other areas, and then trust that they're doing the work that you can rely on. And so, in a sense, we're sort of this technology is driving us to have a higher degree of trust among each other, and I think that's great. But that's always a challenge when you're working in competitive fields and things like that.
Just elaborating a little bit on that, I think many of the most important problems in science transcend the traditional disciplines that we've had at our colleges and universities. Very rarely is something all physics or all biology or all medicine. They're very often combinations of fields that lead to the most promising discoveries. And I think that's going to be even more so. And it's just an elaboration of what Stephen was saying.
And I think I can just add just a tiny bit on that. I think it's important for people who go into science or engineering or technology that they do sort of get as part of their educational experience a broad range of subjects and not overly specialized right at the start.
Yeah, I agree with that. Yeah.
Okay, we've got another question that's come in from Alice Popejoy. Dr. Fox, thank you for setting an inspiring example for women and girls in STEM fields. We all know that there is a gender gap in high-level science careers. What motivated you to be successful, and what advice can you give young investigators for advancing their careers to the next level?
Well, I hope you don't mind my disclosing my age by saying I was in the end of the 8th grade when Sputnik was launched. But there was a strong encouragement at every stage for boys and girls to at least think about careers in science. And if you thought deeply about science, you had the really quite straightforward consequence of loving it. So I ended up loving it when I was in the equivalent of a junior high school, and I've never looked back. I can't imagine my life without some part of discovery and science investigation as key ingredients.
Okay, the next question comes from Sean Bedwell. Sean asks, what would your second job be if science was not around today?
Anything?
I don't know, your second job, anything.
How much money do we have to make?
I suppose it would be a university chancellor. I love my job.
Any other second careers? No.
No.
Okay. Well, I've got this question comes from G. Alan Miller for Dr. Washington, my 11-year-old son would like to know if you have any theories on ways to reverse global warming.
Wow, I don't know if we can reverse it. It would be nice if we could do it, if we could find a way to take carbon dioxide out of the atmosphere. But I think, well, it may be possible to sort of do that, but the technology hasn't arrived yet. But I think the next best thing is to cut emissions of greenhouse gases.
Okay, this is our last question. I think that this is a great one to close on. This comes from Anne-Marie Mounts. She asks, what does receiving the National Medal of Science, you're the National Medal of Technology and Innovation. Yes. So for you, technology and innovation, for the rest, science, what does it mean to each of you, both personally and professionally?
Well, I think for me, it really represents a field that is emerged where in the early days I don't think that we would imagine that we could simulate the climate on the computers. But it's important to emphasize that this isn't just me. It's a team of scientists and engineers and computer experts who have worked as a team to be able to model on the atmosphere and the climate system on modern day supercomputers. And I think on the receiving of the medal honors not only me, but many of my colleagues.
To me, and the Technology and Innovation Award is just it's a great thing. I'm really moved by it. You know, I started doing digital photography very early on, and it was just a real crude technology, and it was basically dreams. And then to be fortunate enough to participate over the last 35 years with an absolutely fantastic team at my company, Eastman Kodak Company, and working with thousands of men and women there to help develop that field into the present field that everybody seems to like and use today has been very, very gratifying. So to be recognized this way, as Warren points out, you're just one person in a whole group of people that's trying to do something interesting and helpful, and so it's a really great honor.
I felt much the same way, that in doing the work is really rewarding in itself, and having colleagues and students in particular who you could observe growing from rather immature textbook scientists to really practicing scientists who are inventive and are going to generate the next round of technology and help the government make data-based decisions is very, very important. Not only for me, I think anyone, there are many people who have done things that won't have the chance to be so honored, and so I'm appreciative of that. But also just because it brings together so many different people in support of what the world needs and what the United States needs.
Well, thank you so much, Warren, Steve, and Marianne, for joining us. Thank you to everyone that was involved in participating in the conversation on whitehouse.gov and Facebook. This video will be posted shortly on whitehouse.gov, and be sure to watch the live stream of the awards ceremony tomorrow on whitehouse.gov. There will be more information there, and have a good afternoon.